Okay, welcome to a lecture. This lecture was actually recorded, but I forgot to turn on my mic. So this is the second time I'm recording the same stuff. I hope I can explain it more correctly this time if I've made any mistake in the previous lecture. So, tough. Oh, okay. Let us begin. In this lecture, we're gonna see about plane wave propagation. So plane wave propagation, what does it mean? Now imagine you are in a swimming pool. You have dropped a phone. Okay, so when you drop the phone, the area becomes as such, the water becomes in this shape until in a specific moment the water becomes straight. So this is what we call as plane wave propagation. So what does it mean? It means that when the phone dropped, it started as a spherical orbital wave, but soon enough it became straight. So that means plane wave, straight wave propagation. Propagation means the movement of it. Okay, now what does lossless media mean? Now imagine you have a antenna, a transmitting antenna and receiving antenna. So you just transmit, you just receive in an open air. This is means lossless media because nothing is being lost. But imagine if there's a building here, there's a building here, there's a building here. It becomes hit here, transmit back, then it comes here, it reflects back. So it's being lost. So lossless media means it's something that doesn't affect the wave. Okay, now there are three criteria for lossless media. One is no attenuation, so the A should be 0. What is A? It would be given in the question, and the wave should travel in z-axis. Why z-axis? If you take normal xy plane in a graph paper, you notice that you will plot the graph in a 2-dimension. So how do you say that this is behind the another x, this is in front of the another x? You should have the z plane. So our propagation graph would be x, y and z. So it would become as such. So it's just the same, we just replace it or move it in a 3-dimension. Our normal x, y would become as such. So we add the z, then we make it z around. So it's just the same. Alright, so the second one is we need to remember c is equivalent to 3 times 10 power of 8, which means that it travels in the speed of light. Then the third is that it has the intrinsic impedance, meaning that the n node is always equivalent to 120 pi or equivalent to 377, which means natural electrical resistance on space. As an example, lossless media means it's in the air, it's in the vacuum. So this is something that needs to be known for this NO. Okay, and there are certain stuff that you need to remember. One is angular frequency is equivalent to 2 pi f, and the second is power in a certain point is equivalent to power density and the area, and power density is equivalent to the power, the total power of by 2 and the natural resistance. And this is something you need to remember too. This would help us. So okay, now the relationship between electric field and magnetic field and the propagation, we need to study a bit about this. So electric field we denote it as E, magnetic field we denote it as B, and propagation we denote it as K. Now changing electric field creates changing magnetic field. This is said by Ampere's law. Changing magnetic field creates changing electric field. This is said by Faraday's law. Now, continuous self-sustaining cycle allows the wave to travel. Imagine, just imagine. Now, this is my electric field. So, this electric field changes. Now, this changing electric field creates a magnetic field. Okay, so use the right hand rule. If my electric is going in this way, so my magnet will go in this way. Okay, so if my magnet is going in this way, so my electric will be going in the another way, so it would create as such loop, and this would create as such loop. So this creates this, and magnet creates electricity, electric creates magnet, it creates, and the wave goes as endless. So this is what they are trying to tell us. Okay, this is what they are trying to tell us in this way. Now okay, great. Now the second thing is electric field and a magnetic field are orthogonal. How? Electric field is as such, magnetic field is as such, electric, magnetic, so they are 90 degrees apart from each other. So if it's one in x, one in y, it means it's 90 degree. The next is reach their maximum strength and cross zero at the exact same time. How? Magnet, current, magnet, so this goes as this, and this goes as this goes as this, and this, so the zero and the peak are at the same time. Okay, now this is denoted as a equation where k, the propagation, is always with e by the b, meaning that it's cross product direction, right hand rule, just as I showed just now. Now plane wave propagation facilitates transmission of electromagnetic signal. I said plane wave means it's straight, uniform. So plane wave travels in a single uniform direction, can point transmitting to receiving. So it's not curved, it's not in bell shape, it's not reflected, so it's in straight, which makes the mathematics more easier for engineers, debugging easier. So if you want to debug this specific wave, it's easier. Then you need to calculate the sine, the cos, the angle of refraction and all. So electric field exerts a force of electron inside the antenna metal and back and forth at the same time. So it would be easier for engineers and mathematicians to calculate this single stuff rather than making it more harder using angle and such on. Okay, now we have certain question that we need to see on, so it would be easier for us to understand about propagation more easy. Now if you remember, I said that we need to have this. Okay, so this is we revert back to our original we'll write in this marker from now on. Oh, do we have the color? Yeah, good. Okay, we are back. Never mind, we use the Petronas color. Now P is equivalent to SA. Okay, okay, P is equivalent to SA. Now what is S? S is the power density and A is the area. So now for the first question, they say that radiated by the sun, and B is the intercepted by the earth, C is the electric field of the power. Now assuming that the solar illumination is at single frequency, okay, good, radius of the earth's orbit around the sun, meaning that earth's orbit around the sun is 1.5, meaning that sun's radius is sun's circumference is 1.5. okay, meaning that the whole radius stuff, right? Now and just as they have told us, very good, sorry. And then we know that earth's mean radius is 6.3. okay, now for the first one is total power radiated by the sun. Now by the sun, we know that S is 1 kilowatt, meaning that 1 times by 10 power of 3. okay, then we know that our area is 4 pi r square, where the r is denoted by 1.5. now this is in kilometer, so we need to change it into meter. So if we change it into meter, we will be getting so this is r power of 2, so this is what we get. So the total would be 2.8 power of 26 watt. Now for the second question, it's just the same. The stuff that would be changing is the area. Why? The area for the earth's radius and stuff is pi r square. So it's just the same. R for this is 6380 kilometer. We change it into meter and we will be getting as, so the total would be getting 1.281017 watt. Okay, now the next is the power density, electric field of the power density. So S is the power density, so we know that S is equivalent to electric field power of 2 for NO. This is what I said just now. Here in the space it's vacuum, so technically our NO is 120 pi. Okay, so if we rewrite this equation, in order to get the electric field, we would be getting our equation as such. So we know that 2 NO is 120 pi and S was 1 kilo ohm, so the total would be 870 volt per meter. So this is how we solve for this. Now we have this, okay, it's just the same but with a minor augmentation. They said sea surface and it's below. Now sea surface is a lossy media. If air, it's lossless media. Sea, can it conduct electricity? Yes, so it loses. Now for lossy media, the S is equivalent, S in this formula. You notice here we will be using NC, E negative 2 AZ cos. It has a direction. Now there are certain stuff that I have forgot to add in this question. So the question actually gave us these values. So the value that was given with the question was, so this was the value that was given, and another value that we will be needing is 200 meter. This is our Z direction, so Z is 200 meter. Now this is our equation. We have our data here, so we just rewrite the equation with the data we have. So E naught, do we have the E naught? Yes, we have. So 4.44 millivolt is 10 power of negative 3. Okay, so this should be squared. Now 2 and the NC was given as 0.044. The direction, sorry, the angle we will be saving for here because it asked for the angle. Now E, the A was given, so 0.126, and the Z was given 200 meter. Now cos, the angle is 45 degree. Okay, so you need to solve this equation. Now you can type it directly in the calculator, or you can do this first as A, this as B, and this as C, and then multiply all together. So the final answer would be Z hat 2.1. So technically it loses, it's near 0. Okay, now let's see another example. So this example is something okay, this example is something that you need to know because this is something that would be asked in the exam, and this is what the lossless media propagation means. Okay, before we continue, I need you guys to remember this formula, and C is equivalent to 3 power of 10 8, and also anything else? Nothing. Oh yeah, NO is equivalent to 120 pi. Okay, then the formula, if you remember, there was a formula written here. So this formula I'll be rewriting here, of course. E K T is equivalent to a direction. Technically it's always X, but we'll make it such. And then E naught cos angular frequency T K slash plus T. Now what is this? This would be given the question, and what is this? This would be given the question as well. So this is E. Now we would be doing for h as same too. So for h naught cos wt minus k minus, it's not minus, it's actually the placeholder. So h naught is equivalent to E naught with the natural resistance or what resistance they have given. In this case it's natural resistance in air. Okay, so what can we know from here? So f is equivalent to 1 megahertz. Then we know that our angular frequency is 2 pi f, which is equivalent to 2 pi 10 6, because this is 1 times by 10 power of 6. And then our lambda, something that we need to know, is equivalent to 2 pi over, our lambda is equivalent to c over f. C means it's 3 power of 10 8. So 1 power of 10 6, you will be getting 300 meter. SI unit, if you want to write, or else try to write. 2 pi over lambda is equivalent to, one moment, just one moment. Okay, I am speaking. Good. Okay, 2 pi over lambda, which is equivalent to 2 pi over 300 ret over m. Okay, then do we have it complete? Not yet. So E naught. In the question they said that the peak value 1.2 pi. If this field, what field? Electric field, and it said is moving in the z direction. So this is z and here is z, and electric is in the x direction. So hz, if electric in the x direction is moving in the z direction, the magnet is in the y direction. What am I blabbering now? Assume x, assume y, assume z. So the wave is traveling in z direction, meaning the balance in x and y. So it's moving in the z direction. So here we write the z, kz. Now the balance is these two. We need to find which vector position it's moving. So electric in the E. So the balance is y. So the magnet is in the y. Okay. So this was what I was trying to say. Now we know that E naught is equivalent to 1.2 pi, and they say millivolt. So this value will be needed soon. Okay. So write E z t is equivalent to 1.2 pi E naught, the x vector for electric field, 1.2 pi cos angular frequency was found 2 pi times 10 6 t minus k was found to 2 pi over 300 z plus by as such. Now they said that reaches peak value 1.2. So this 1.2 is actually the peak. Okay, so what is peak? E z t is 1.2 at t equals to 0 and z equals to 50 meter. Now in this question it said that it's 1.2, meaning that 1.2 is equal to 1.2 pi blah 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 shit. Okay, sorry, 1.2 pi is equal to 1.2 pi. Now we know that 1.2 pi times by cos and everything in this should be giving us the answer. So 1.2 pi is equal to 1.2 pi times by cos x. So cos x should be equivalent to 1. So how does cos equivalent to 1? Only if cos 0 is equivalent to 1. So cos 0 equivalent to 1, meaning this everything is 0. So 1.2 pi cos 0 is equivalent to 1.2 pi. It's peak value. Okay. Now in order to get cos equivalent to 0, meaning that everything here should be 0. So let us try to solve it here first. So we know that t is 0 and z is 50. Okay. Now 2 pi 10 6 0 minus 2 pi 350 plus with this should be equivalent to 0. What does it bring to? negative 100 by 300 plus this is equivalent to 0. So this is equivalent to pi over 3. Now we have found this. Very good. So our propagation equation is equivalent to, so it's complete. Now we notice that the E peak value was mv over m. Nice. Now we have the electric field. We need to find the magnetic field. Now remember this. So H naught is equivalent to E naught over N naught. So our E naught was 1.2 pi millivolt, meaning 10 negative 3. So divided by N pi, which is equivalent to 120 pi, you will be getting 10 times by 10 negative 6, which is equivalent to 10 micro am. So this is our H naught. As usual, H, Z, T, and the vector was y hat, and H naught is 10. Then you write the balance as from here. Cos, angular frequency is just the same, 2 pi times 10 60 minus 2 pi 300. Z plus pi 3, just the, okay. Now you have the electric, you have the magnetic. Now this is how you draw it. Now x vector, so here the x, we have the electric field, okay, so it goes up and down. Now H is in the y vector, y, it's going in the z direction. So complete. Nice, very good. And just now, as we said, 0 in the same position, peak in the same position, okay. Now another question. Now just now we saw a lossless medium. Now we see a lossy medium. How, why, when? So it's not, they have said lossless non-magnetic medium, so it's still lossless, but there's a catch. Okay, they have given us permittivity. So lossless medium, then they gave us permittivity. The equation changes a bit. So how does the equation changes? We still use the original stuff, but with a different approach. Okay, so the original equation just now we had was E over something, T equivalent to the vector cos, angular frequency K something, plus with the plus and the unit. Now read the question, take the stuffs first. You have permittivity equal to 9, then peak value equal to 6, then you have, okay, this is the peak value, then suddenly you have the intensity means that E on the time is 4, okay. Then they said Y, so you know that it's traveling in the y direction. Because it's traveling in the y direction, meaning that you need to find the electric field is in the x direction. So electric in the x direction, and you complete the equation. So automatically you know that your magnet, it's in the z vector, okay. How? Imagine xy, okay, x y z. So you're traveling here. If you're traveling here, your x is the electric, so your z would be the magnetic, right? Just you have 3, change it. Now we have everything that we need. So we have f as 1 gigahertz, which is equivalent to 10 power of 9. Then we need to find angular frequency, which is 2 pi 10 over 9. Then we need to find lambda. But before we need to find lambda, we have certain things to know. If a lossless media, the permittivity is equivalent to 1. Okay, now we need to find UP, which is equivalent to C over permittibility and permittivity, which is equivalent to C. We know that it's equivalent to 3 times 10 power of 8 root of 1 times by 9, which is equivalent to 1 times, okay, you notice here, this is the permittivity, This is the permittivity, sorry, this is the permittivity, this is the permittivity. So technically we will be doing is lambda is equivalent to C per F. But in this case we need to solve this first, because lambda is equivalent to UP over F. So our UP is 1 times 10 8, our F was 1 times 10 9, which is equivalent to 0.1 meter. Now using this we can find K, 2 pi F, which is 2 pi over lambda, which is 2 pi over 0.1, which would be giving 2 pi. Okay, so we have all the data. Now we try to fix it. EYT is equivalent to X, and yeah, I forgot E naught, and this is H naught, and in this case H naught should be equivalent to E naught per N, but due to lossless media, the N would be equivalent to N naught, the resistance, over square root of the permittivity. Okay, this is something that we need to know later, but I just write it here. So the peak value was 6. This is the unit. 6 cos angular frequency, we know that it's 2 pi power of 9 t minus k was 20 pi y plus such. Now we know that EYT is equivalent to 4, meaning for x, okay, we remove the x vector for a while. 6 cos 2 pi tan 9, they say t 0, so 0 minus 20 pi, they say y is 2 centimeter, so 2 centimeter is equivalent to 0.02 meter. 0.02 meter plus with this 4 is equivalent to this. So you need to compute everything in order to find this. So for 6 is equivalent to cos 0.4 pi plus this. So the final answer would be 2.09. Now you have this, you just plug it in the value, so you would be getting as x hat 6 cos 2 pi tan 9 t minus 20 pi y plus 2.09. Now H naught is equivalent to E naught over N, but before that we need to find our N. Now N is equivalent to N naught, 120 pi over square root of permittivity 9, which is equivalent to 120 pi over 3, which is equivalent to 40 pi. So H naught is equivalent to 6 over 40 pi, which is equivalent to 0.0477. So rewrite everything. H y t in the z direction, because we noted 0.0477, yeah, this is voltage per meter, cos 2 pi tan 9 t minus 20 pi y plus 209 in the AM. Okay, so this is for this lecture. Thank you.